Silicon Valley. The VTA is expected to approve a single-bore tunnel design that would have trains running beneath downtown San Jose.
For decades, China has dominated the world in massive infrastructure development, earning a reputation as the undisputed leader. While China pushed forward, the US seemed to lag behind. But times are changing quickly. As of September 2025, America is building incredible megaprojects that could rival China's dominance and take the world by surprise. Get ready to explore these groundbreaking developments that signal a new era of competition in global infrastructure. The Silicon Valley BART extension. The USA wants to integrate the Bay Area's transportation network with the fast-growing cities of Santa Clara County. Originally conceived in the late 1990s, the Silicon Valley BART extension is the answer to this challenge. The project is managed by the Santa Clara Valley Transportation Authority, or VTA, in partnership with Bay Area Rapid Transit, or BART. The extension carries particular importance because Santa Clara County, with more than 1.9 million residents, was the largest county in the Bay Area not directly served by BART when the system first opened in 1972. The program aims to close this long-standing gap by extending BART service from its former southern terminus in Fremont deeper into San Jose and eventually Santa Clara. The first phase of the extension, known as the Berryessa extension, broke ground in 2012 and opened to the public on June 13, 2020. This segment added 10 miles of track and 2 stations, Milpitas and Berryessa North San Jose. The cost? Approximately $2.3 billion. The alignment followed the Union Pacific Railroad corridor, requiring right-of-way agreements, relocation of utilities, and careful integration of traction power substations and signaling systems. The Milpitas station was designed as a multimodal hub, connecting BART directly with VTA light rail services and regional bus routes. The Berryessa station, meanwhile, became the first BART station within San Jose city limits and a major commuter access point for East San Jose residents. Phase 2 of the Silicon Valley BART extension represents a far greater engineering challenge and is currently one of the largest infrastructure projects in the United States. Estimated at $12.2 billion, this 6-mile segment will extend service through downtown San Jose to the city of Santa Clara, with 4 new stations: Alum Rock, 28th Street, downtown San Jose, Diridon, and Santa Clara. The alignment requires roughly 5 miles of underground tunneling, making it one of the most extensive subway projects in California since the construction of the Los Angeles Metro Red Line. The chosen method is a single-bore tunnel design, approximately 48 feet in diameter, large enough to house both tracks stacked vertically, along with maintenance walkways and emergency systems. A tunnel boring machine will advance beneath densely built urban areas, including San Jose's historic core, at depths ranging from 30 to 70 feet. The engineering complexity of this phase cannot be overestimated. Santa Clara Valley soils range from expansive clay to liquefaction-prone sands, requiring a combination of soil stabilization methods, deep foundations, and continuous monitoring. Construction teams have adopted ground freezing and pressurized TBM techniques in sensitive areas to limit settlement and protect surface structures. Seismic resilience is built into the tunnel lining, which uses precast concrete segments with gasketed joints to maintain water tightness and structural integrity during earthquakes. These design features are critical in an area crossed by several faults, including the Calaveras and Hayward faults, both capable of producing major seismic events. The new stations themselves represent transformative nodes for regional mobility. The downtown San Jose station will provide direct access to the city's commercial core, while Diridon Station, already served by Caltrain, Amtrak, ACE, and future California High-Speed Rail, will become one of the largest multimodal hubs on the West Coast. Santa Clara Station will link BART with existing commuter rail lines and the Mineta-San Jose International Airport area. Each station is being designed with accessibility, energy efficiency, and high passenger throughput in mind, featuring escalators, elevators, platform screen doors, and advanced ventilation systems. Funding for the Silicon Valley BART extension has come from a mix of local, state, and federal sources. Santa Clara County voters twice approved sales tax measures in 2000 and 2008 to help finance the project, while in 2018, the Federal Transit Administration committed $125 million in grants toward Phase 2 through its Capital Investment Grants program. Despite cost escalations and schedule revisions, the project remains a centerpiece of California's long-term transportation planning, with completion of Phase 2 currently projected for the early 2030s. The extension is expected to serve more than 50,000 daily riders. Impressive, right? Well, there's more from where that came. Puget Sound Gateway Program. Managed by the Washington State Department of Transportation, or WSDOT, the Puget Sound Gateway Program focuses on completing critical missing links in two highways, State Route 167 in Pierce County and State Route 509 in King County. These highways were originally planned in the 1960s as part of a broader regional network, but their final connections to major ports and interstates were never built. As a result, freight trucks, commuters, and shippers have long faced bottlenecks and congestion, particularly near the ports of Tacoma and Seattle, two of the busiest container gateways on the U.S. West Coast. The program was formally authorized by the Washington State Legislature in 2015 through the $16 billion Connecting Washington funding package. The overall estimated cost of the Gateway program is $2.38 billion, funded through a combination of state gas taxes, federal grants, and local contributions from port authorities and regional agencies. Construction activities began in earnest in 2018, with phased contracts designed to minimize disruption while advancing both 167 and 509 simultaneously. In Pierce County, the program's centerpiece is the completion of SR 167, a project decades in the making. The highway currently ends abruptly near Puyallup, creating a gap between Interstate 5 and the Port of Tacoma. The Gateway program will extend State Route 167 by 6 miles to connect directly with Interstate 5 and State Route 509, dramatically improving access for port-bound trucks. The design includes new high-capacity interchanges at Interstate 5, State Route 161, and State Route 509, as well as direct ramps to industrial areas adjacent to the port. By creating a seamless freight corridor, this extension is expected to reduce travel times by up to 20 minutes for trucks hauling goods between distribution centers in Pierce County and marine terminals on Commencement Bay. In King County, the program advances State Route 509, a corridor that historically has not been completed to its intended capacity. The Gateway program will extend State Route 509 by approximately 3 miles south from its current terminus near SeaTac Airport to Interstate 5 in the city of SeaTac. This connection is especially critical for both freight and passenger traffic. For freight, it provides a direct link from the industrial Duwamish and Kent valleys to the interstate system. For passengers, it opens an additional route to Seattle-Tacoma International Airport, which served nearly 52 million travelers in 2023.
This week, we've taken you all over the Bay Area, showing you the biggest road construction projects.
Construction crews are now building multiple bridges, extensive retaining walls, and deep foundations to withstand both geologic instability and potential earthquakes from nearby faults such as the Seattle Fault Zone. Mass grading operations are reshaping large tracts of land to accommodate new lanes and interchange footprints, while stormwater treatment systems are being integrated to protect sensitive wetlands and waterways. The economic stakes are substantial. The combined ports of Seattle and Tacoma, operating together as the Northwest Seaport Alliance since 2015, handle more than 3.3 million 20-foot equivalent units of cargo annually, ranking as the fourth largest container gateway in the United States. By closing gaps in the freight highway network, the program supports faster, more reliable access to terminals, distribution hubs, and rail yards. West DOT projects that the program will save freight carriers and motorists over $3 billion in travel time and fuel costs over the next 30 years. Additionally, improved port connectivity enhances the competitiveness of Washington's export economy, particularly for agricultural products, aerospace components, and technology goods. Green Link West Transmission Project. Managed by NV Energy, Nevada's largest electric utility, the Green Link West Transmission Project involves the construction of a 525 kilovolt alternating current transmission line that will stretch across hundreds of miles of desert, mountain, and rural landscapes. Announced in 2020 as part of a $2 billion package of grid modernization investments, GreenLink West is complemented by its sister initiative, GreenLink North. Together, these projects form what NV Energy calls the GreenLink Nevada system, a framework that will connect renewable energy zones across the state with population centers and regional power markets. GreenLink West, specifically, will run for approximately 350 miles, linking a new substation in Las Vegas to another in Yerington, Leon County, in western Nevada. By crossing Clark, Nye, Esmeralda, Mineral, and Leon counties, the line provides a backbone connection across some of the state's most isolated regions. The 525 kilovolt capacity is notable because it represents the highest voltage class of AC transmission widely deployed in the United States, enabling bulk power transfer over long distances with reduced line losses. The line uses a combination of lattice steel towers and monopole structures, chosen based on terrain and environmental considerations. Lattice towers, often standing over 150 feet tall, are deployed in open desert valleys where wide footprints are possible. Monopoles, which are slimmer and less visually obtrusive, are installed in tighter corridors or near communities. Helicopters are being used extensively to transport tower components and string conductor cables across rugged mountain ranges and inaccessible desert plateaus, minimizing the need for intrusive ground access roads. These aerial construction techniques reduce environmental disturbance while accelerating the installation process. Then there's the environmental stewardship. Much of the line passes through habitat critical to the Mojave Desert tortoise, a federally threatened species. NV Energy has worked with the U.S. Fish and Wildlife Service to implement monitoring programs, fencing, and relocation protocols to minimize harm to the tortoise population. Erosion control measures, including slope stabilization and sediment barriers, are being deployed in areas with fragile desert soils to prevent runoff during seasonal rains. Additionally, revegetation efforts are planned along disturbed corridors, using native plant species to restore ecological balance and reduce the spread of invasive weeds.
Sturgeon Electric Company has reached new heights with the successful completion of the 500 kV One Nevada transmission line.
At either end of the line, new substations are being constructed with advanced grounding systems, protective relays, and supervisory control and data acquisition interfaces. The Green Link West project is also a cornerstone of Nevada's broader clean energy strategy. The state has set statutory goals to reach 50% renewable energy by 2030 and 100% carbon-free electricity by 2050 under Senate Bill 358, signed into law in 2019. GreenLink West is critical to achieving these targets because it provides the transmission backbone necessary to connect large-scale renewable facilities, particularly solar, geothermal, and future wind projects, with demand centers. Already, NV Energy has secured contracts with multiple renewable developers anticipating interconnection to the GreenLink system, with individual solar projects often exceeding 200 megawatts in capacity. The project is expected to create thousands of construction jobs and inject hundreds of millions of dollars into local economies through material purchases, contractor services, and land use agreements. Once complete, the transmission line will help stabilize Nevada's grid, reduce reliance on out-of-state power imports, and enhance resilience against extreme weather events or regional supply disruptions. Create program.
CREATE program is a very special partnership that really came out of a crisis of need when we couldn't get freight.
The Chicago Region Environmental and Transportation Efficiency Program, better known as CREATE, is one of the largest and most ambitious rail modernization initiatives in the United States. Launched in 2003 as a $4.6 billion public-private partnership, the program was designed to tackle the chronic freight and passenger rail congestion that had plagued Chicago for decades. As the busiest rail hub in North America, Chicago handles about 1/4 of the nation's rail traffic, with more than 1,300 trains, freight and passenger combined, passing through the metropolitan area each day. This sheer volume has historically caused severe bottlenecks, with some freight trains taking more than 30 hours to pass through the city, delaying goods shipments nationwide and creating ripple effects across the supply chain. CREATE aims to systematically eliminate these choke points through more than 70 infrastructure projects. A central component of CREATE involves constructing rail-to-rail grade separations, also known as flyovers, that allow intersecting rail lines to cross without impeding each other's movements. One of the most high-profile examples is the Englewood Flyover, completed in 2014 on Chicago's South Side. This $142 million project eliminated a major conflict point between Metra's Rock Island commuter line and Norfolk Southern's busy freight line, easing delays not only for local commuters but also for Amtrak trains on long-distance routes such as the Cardinal and Crescent. Additional flyovers, including those at 75th Street and Belt Junction, are part of ongoing phases of the program and are considered critical for untangling the dense web of rail traffic in the city. Beyond rail-to-rail conflicts, CREATE also targets highway rail grade separations, where road traffic and rail lines intersect. Chicago and its suburbs have historically had hundreds of at-grade crossings, many of which contribute to congestion, safety hazards, and delays for both motorists and rail operators. Under CREATE, dozens of these crossings are being replaced with overpasses or underpasses, separating rail lines from vehicle traffic altogether. Then there's the integration of stormwater management systems, since Chicago's flat terrain and history of flooding necessitate advanced drainage infrastructure. Technological upgrades form another backbone of CREATE. The program includes modernization of centralized traffic control systems, which allow dispatchers to manage rail movements more efficiently across the Chicago terminal area. This has been complemented by the installation of Positive Train Control, a federally mandated safety system that prevents train-to-train collisions, derailments from excessive speed, and incursions into work zones. Fiber optic networks have also been deployed across corridors, providing real-time data transmission that supports not only rail operations but also advanced diagnostics for infrastructure health and maintenance needs. Chicago has been known as the nation's rail hub since the 19th century. Improving its efficiency has direct benefits for agricultural exports from the Midwest, intermodal shipments arriving from West Coast ports, and manufactured goods heading to East Coast markets. John Glenn Columbus International Airport expansion.
John Glenn Columbus International Airport. New traffic pattern changes started today. This includes some lane restrictions and relocated parking.
Located just east of downtown Columbus, Ohio, the John Glenn Columbus International Airport is undergoing one of the most significant infrastructure projects expansions in its history, aimed at meeting rising passenger demand and positioning the airport as a more competitive hub in the Midwest. Originally opened in 1929 as Port Columbus Airport, the facility has long served as a gateway to the state capital and the surrounding region. By 2016, it was renamed John Glenn Columbus International Airport in honor of the Ohio-born astronaut and U.S. Senator. Passenger traffic has steadily grown over the past 2 decades, with the airport handling nearly 9 million travelers annually before the pandemic. Forecasts by the Columbus Regional Airport Authority suggest that passenger volumes could climb to more than 11 million in the coming years, necessitating a large-scale expansion and modernization program. At the heart of this expansion is the construction of a new passenger terminal designed to replace the current mid-20th century facility, which has been expanded several times but is now at the limits of its operational capacity. The new terminal will feature larger security screening areas to accommodate TSA's latest standards, along with an advanced baggage handling system equipped with high-speed conveyors and inline explosive detection technology. The expansion also addresses the airport's airfield infrastructure, ensuring it can support the operational demands of modern commercial fleets. Taxiways are being widened to meet Federal Aviation Administration Group 5 standards, which accommodate larger aircraft such as the Boeing 777 and Airbus A350. High-speed taxiway exits are being constructed to reduce runway occupancy times, a feature that improves efficiency by allowing aircraft to clear runways quickly after landing. In addition, reinforced pavements with upgraded load-bearing capacity are being laid to extend the lifespan of critical surfaces and to handle increased aircraft operations projected over the next several decades. These airfield improvements are coordinated with FAA Airport Improvement Program funding, which provides federal grants. On the land side, the airport is undergoing a reconfiguration of access roads, drop-off areas, and parking facilities to handle higher volumes of ground traffic. A new roadway system is being built to streamline the flow of vehicles entering and leaving the terminal area, reducing congestion that has long been a challenge during peak travel periods. Passenger drop-off and pick-up zones are being expanded. Parking expansions include both surface lots and multi-level garages, with smart technology such as real-time occupancy tracking and mobile payment systems being incorporated. Moreover, the terminal and associated facilities are being equipped with redundant electrical feeds, reducing the risk of outages that could disrupt operations. Backup power systems, including diesel generators and provisions for future battery storage integration, are being installed to ensure continuity during grid disturbances. Telecommunications infrastructure is also being modernized with new fiber optic conduits, supporting not only passenger-facing services such as Wi-Fi, but also advanced airport operational systems that rely on real-time data. Portal Bridge Replacement. The Portal Bridge Replacement in northern New Jersey is a pivotal upgrade along the Northeast Corridor, the busiest passenger rail line in the U.S.
450 trains cross the old Portal Bridge every day, carrying some 200,000 Amtrak.
The original two-track swing bridge, built in 1910, has long been a notorious choke point due to its aging design and frequent mechanical failures. Carrying about 450 daily trains and over 200,000 passengers, the bridge's movable span often disrupts service when opening for marine traffic. The replacement project, managed by Amtrak and NJ Transit with federal funding, will build a modern fixed-span bridge 50 feet above the Hackensack River, eliminating the need for openings and improving reliability, speed, and capacity. Construction involves deep foundations, steel girder spans, and modern electrical and signaling upgrades. Once complete, the old bridge will be dismantled with ecological safeguards. Newark Elizabeth Airtrain Project. The Newark Elizabeth Airtrain Project is a $2.7 billion modernization effort by the Port Authority of New York and New Jersey to replace the aging Airtrain Newark, in service since 1996.
And the Newark Airport station, after service was disrupted about 4 o'clock this afternoon, a train was stuck.
The current system, carrying more than 11 million passengers annually, suffers from breakdowns, rising maintenance costs, and limited capacity. The new dual-track elevated system will link Newark Liberty International Airport's terminals, parking, rental car center, and Northeast Corridor rail station, while extending into Elizabeth to strengthen regional transit connections. Built on precast concrete guideways with deep foundations engineered for seismic and wind resilience, the AirTrain will feature state-of-the-art communications-based train control, automated operations, and enhanced safety measures. Construction is carefully staged around the airport's 46 million annual passengers to minimize disruption. The project will improve access, reduce congestion and emissions, and provide faster, more reliable and sustainable mobility for decades to come. Well, that's it for now. Thanks for watching. Did you like this video? If you did, please consider liking, dropping a comment, and hitting the subscribe button so that you don't miss out on our new uploads. Also, don't miss this video you see on your screen right now. It's truly unbelievable.